Welcome to topic number 11, simple interest. If it were not for compound interest and depreciation that are also included in this presentation, it would have been one slide long. Simple interest will be done in a short revision and the others will be handled with a bit more rigor. Some of the techniques learned in the other topic will be made use of, especially when working with depreciation and compound interest. The power of scientific calculators and computers will be highlighted, as without them, the recent innovation in the calculation of compound interest would not have been possible. Jamaica Money Market Brokers is the first institution that I have heard of that gives interest that is compounded daily. I am sure that by now they are not the only one. The technique used to increase an amount by a given percentage in one step will prove beneficial. An extension of the principle will be amplified in order that an increase by a given percentage may be done any number of times in one line. Since there is no great problem to be encountered while working with simple interest, let us go into the meat of the matter. That is our formula for simple interest, principal times rate times time over 100, that we have done from primary school. Principal, this is the amount of money invested or borrowed. Rate is given as a percentage, hence the 100 in the denominator, and time, this tells the period over which interest is charged. Let us transpose the formula in order to derive expressions for each of the symbols involved. First, make T the subject of the formula. So that is our formula to the original. So if we want to make T the subject of the formula, we need to multiply by 100 on this side, then we divide by PR. So 100i over PR is equal to T, and of course we may turn it so that the subject of the formula, which is T, is on the left hand side. And next, make R the subject of the formula, and we progress in the same way. Getting rid of this 100 here, multiply by 100 on that side, and then divide by PT. Of course, R is equal to 100i over PT. And finally, make P the subject of the formula. What do? We multiply I by 100 here on that side, since we are dividing by 100 here. Then if we're going to make P the subject of the formula, we have multiplied by R and T here, so we have to divide on the other side. So we're going to have 100 times I. These two that are multiplied on this side are going to be divided there. And of course, we are going to turn around, and that's what we get. I do not know of any student who cannot remember the formula for simple interest. No emphasis will be placed on the basic formula, which is that one. The other formulae are quite similar if they are examined closely, not similar to the one that we have above, but similar to each other. If they are examined closely, it can be seen that any one of the other symbols that we need to make the subject of the formula is equal to 100 times the interest divided by the other two, or the product of the other two. Let us look at them. 100 multiplied by the interest, that is what we have in the numerator all the time. And in the denominator, what do we have? The denominator contains the other two symbols. There they are. Right. What is the simple interest on 2,500 when it is invested for 2 years at 8% per annum? That is our formula. Insert the values in their appropriate place in the formula, and this is what we will get. So the principal goes right there. The rate is 8, and the time is this. Don't forget that the rate is given as a percentage. That is why we always have this denominator of 100. And when we work that out, we just get $400. There is no twist nor turn in the problem, and the figures are straightforward. What is the simple interest on $7,800 that was invested for 2.5 years at 12.75% per annum. The fractions may be a little alarming. We may rewrite them as improper fractions. So 2.5, we say 2 2's 4 plus 1, 5, 5 over 2. 4 12's 48 plus 3, 51 over 4. So when these are substituted into the formula, the numerators are placed at the top and the denominators are placed at the bottom. So we are going to put that in the formula. That is our formula. That means where we see the rate, what is the rate? 12.75, which turns out to be 5 over 4. So 5 is going to go in the numerator and 4 in the denominator. And the time is 2.5, which is 5 over 2. So 5 in the numerator, 5 in the numerator, and 2 in the denominator. So that is what we have. And of course, we simplify those. See, it's clear that we have 5 over 2 here, 5 in the numerator, 2 in the denominator. And the other one is like that, with 51 over 4. So 51 in the numerator and 4 in the denominator. Of course, when that simplifies, it gives $2,486.50. The numbers containing fractions may also be written in decimal form. So the numbers, if we have fractions, they may be written in decimal form. So instead of writing 2.5, we may write 2.5. Instead of writing 12.75, we may write 12.75. And then we have no new denominators, so we just multiply like that. All of these numbers are in the numerator, and then we simplify, we get the same answer as we did before. Where necessary, the fractions may be reduced. Otherwise, a calculator may be used. Now we are going to be looking at the principal. The question is, what is the sum of money that should be invested at a rate of 8% per annum in order to get an interest of $500 after 4 years? So we have everything else except the principal. So we need to find the principal. We are required to find the sum invested. This is the principal. Remember that apart from the interest, each other symbol in the formula is equal to 100 times the interest over the product of the other two. So in order to find the principal, we know that it's going to be 100 times the interest over the rate times the time. Like that. And of course, all we need to do is substitute the values that we have right there into the... Substitute the values in their respective places and just simplify. Of course, the simplification process needs no introduction at this level. Our answer is $1,562.50. What is the rate percent when $2,500 was invested for 3.5 years and yielded an interest of $800? So what is the rate? So we need to find rate. So the rate is equal to 100 times the interest over principal times time. So the rate is equal to 100 times the interest divided by the product of the other two. And of course, when they are substituted in the formula, that is what we are going to get. And the rate is 9.1%. How long? What does how long mean? Time. So how long should $10,000 be invested for in order to accumulate an interest of $5,000 at a rate of 15% per annum? How long will we have to invest that money? Time is equal to 100 multiplied by interest divided by the product of the other two. Substitute the values in their respective places, and that is what we'll get. And of course, the simplification will give 3.33 years. And by looking at that 0.333 going all the way to eternity, we know that it's 3 1/3 years. Now we are going to be taking a look at compound interest. When interest is compounded, the duration of time is usually divided into equal periods. The interest after the first period is added to the principal, and the sum becomes the new principal. So when you get your interest, you add it to the original principal, the sum becomes the new principal, you use this new principal for the new period. Right. So the interest after the first period is added to the principal, and the sum becomes the new principal for the next period. This continues until the number of periods is exhausted. What is the total amount of money that Mr. Johnny Cash will have in the bank after 3 years if he invests $20,000 at a rate of 12% per annum, and interest is compounded annually? Interest is compounded annually. This means that the period is 1 year long. In the compound interest, the value of time is usually 1. Any number multiplied by 1 is equal to 1. Therefore, 1 is usually disregarded in the calculation. That is our same problem with Mr. Johnny Cash. And let us see what happens. After period 1, increase $20,000 by 12%. Do not forget how to do this the short way. How do we do that? Increase by 12%, 112%, divide by 100, 1.12. Is that all? Okay, there we go. Multiply by 1.12, and that is your answer. The total becomes the new principal for the period 2. So the total is going to become the new principal for period 2. And we are going to do the same thing. Multiply that by 1.12, which is increasing that by 12% again. Good. That is our next result. And what is going to happen? The total becomes the new principal for period 3. And we need to determine the answer. All right. Remember that the rate that we multiply by, which is increasing by 12%, is 1.12 all the time. In some questions, the interest is required instead of the total amount received at the end. In the event that this is the case, subtract the amount initially invested from the total received at the end. That's all, and we are going to get $8,098.56. When a problem is given, students just calculate without paying attention to what is required. Remember, no examiner is interested in how much mathematics you know. You will never know enough to impress him. Just answer the question. What is the total amount of money that Mr. Johnny Cash invests? So we have the same problem coming up again, but let's see how we take a look at it this time. Let us see what will happen if after every period the expression is left as it is, instead of working it out. So we're not going to work it out. We're going to leave the expression just as it is. We're not going to be looking at the final answer after every period. So let's see what happens. After period 1, increase $20,000 by 12%. Let's see what happens. That is what we get. So we do not want the answer. We are going to use that product for period 2. So the expression after this first period will become the principal for the next period. Right. All of that is the principal for the next period. And what are we going to do next? Yes. Multiply by 1.12 again. Now increase the result by 12% again. Good. The expression derived after period 2 will be the principal for period 3. Good. See what happens? We are going to increase by 12% a last time. Good. Examining the final expression, it can be noticed that 1.2 is being multiplied 3 times. When you multiply something by itself 3 times, what is that? This may be written as 1.2 to the third power. Right. So instead of multiplying by 1.12 all the time, we have 1.12 raised to the third power. So what we have here is equal to 20,000 multiplied by 1.12 raised to the power of 3, because we have 1.12 multiplying by itself 3 times. What is 3? The power, well, the power of course. However, the 3 represents what? The 3 periods. So the total number of periods will be the power that we use in solving our compound interest problems. This expression is useful when the number of periods involved is very large. So if the number of periods that is involved is very large, you will not want to work them step by step by step by step. You will want to just raise that factor that you have there by the power that tells us the number of periods. So let's move on. Let us say that $132,000 was invested for 1 year at a rate of 30% per annum, with interest compounded monthly. Do not forget now, the rate is per annum. And how is it compounded? Monthly. Increasing the new principal 12 times by our short method will still be a great task, much more using our old primary school method. There are some things that we need to bear in mind. Now, if we are going to just say, find 12% of $132,000, then add it to that, then go back again, find the percentage and add it, find the percentage again and add it, that is going to be some tough task. If we are going to use our short method, we are going to multiply by 1.12, then when we get the answer, we multiply by 1.12. There's no danger in that. The greatest problem that we have is sometimes when we are busy putting in the correct figures in the calculator, we do not remember how many times we have done that already, and we are in serious problem. We'll have to start over and over again. The interest given is annual, but it is compounded monthly. We therefore need to determine the monthly interest. To find the monthly interest, we need to divide the annual interest by 12. So 30 divided by 12, so that is our monthly interest. So we are going to be compounding monthly, therefore we need our monthly interest. We are increasing by 2.5%. Add this to 100 and we get 102.5%. The rate is therefore, divide by 100, we get 1.025. The number of periods, 12, is the power. Do you remember that the number of periods that we used turned out to be the power? So let's go. As a matter of fact, let's see if we can figure out what the statement will be even before writing it. So this is going to be increased by what? This rate, 1.025. So we're going to multiply this rate by 1.025. But we have 12 periods, so we need to raise this to the power of 12. Alright, so 132,000 multiplied by 1.025 to the power of 12. And that is all there is to it. If simple interest were used, the amount would have been 171,600. This is smaller than the compound interest over the same period. It therefore follows that the greater number of periods used in compound interest, the greater the value at the end of the entire time. When JMMB started to offer interest that was compounded daily, it was too good to be true for a lot of people. What those people did not understand is that the rate was annual, but compound interest was calculated daily. It is not the rate that is daily that they give you first. They'll give you an annual rate, and then they say that it's calculated or compounded daily. Let us determine the amount of money that a person will receive from JMMB if $50,000 is invested for 2 years at an annual rate of 14.6%, compounded daily. The interest given is annual, but it is compounded daily. We therefore need to determine not monthly, the daily interest. Just divide the annual interest by 365. So we're going to divide the annual interest by 365 in order that we may get our daily interest. Now, this is still a percentage. That means this has to be divided by 100. Anyway, let's add this to 100 first. We are increasing by 0.04%. Add this to 100 and we get 100.04%. The rate is therefore 100.04%, and that we are going to be dividing by 100. So we are going to move this two places, 1 to 1.0004. That's what we get, 1.004. The number of periods, 730. Why? Because we have 2-year period. And 2 times 365 is 730. And this number of periods is going to be the power. So let's see what we get. We have $50,000 and the rate is 1.004. And of course, we have the number of periods, 735 periods. Why? 730 periods, because 365 days in a year and we have 2 years. So that is why we have 730 as a power, representing 730 periods. And this is our answer. We have to use a scientific calculator. And do not think about doing this step by step 730 times. Sometimes the rate is given for a longer period, say annually. Make a simple calculation in order to determine the rate for the specified period, say monthly or daily. The number of periods tell us the power by which to raise the rate. Do not bother to think about calculating the interest after each period for 356 days. Depreciation. Do not be depressed. Calculations made in depreciation are analogous to those made in compound interest. The only difference is that there is a decrease in value rather than an increase. What is the value of a vehicle that experiences a depreciation by 5% each year over a period of 10 years if its initial value was $800,000? So the period, 10 years. And we are going to do it annually for 10 years. So we have 10 periods, so the power is 10. It goes down by 5%, so we have 95%. 95% is 0.95. Right, so we are going to have what? No problem with the period. Interest is given annually and calculated annually, so no problem with that. We are decreasing by 5%. Subtract this from 100 and we get 95%. The rate is therefore 95 divided by 100, which is 0.95. The number of periods, 10, is the power. So that is it. The rate, which is 0.95, is multiplied by, is raised, to the power of 10. And all of that is multiplied by 800,000. And that is our answer that we have right there. In this depreciation, there is nothing new. From working with percentages, we are familiar with decreasing by a specified percentage, the short way. From compound interest, we are familiar with using the rate raised to the power specified by the number of periods. For this subtopic, we do the same. The only difference is that the rate causes the value to go down rather than up.